Hello everyone, in this video we will be trying to discuss the LRU cache, and also we will try and implement it in the TypeScript. So as you can heard of this, LRU cache is a least recently used cache eviction policy. So it's very handy, becomes handy when it's come asked in the interviews. Like it can be also asked in DS. It is very related to the distributed rate limiter or distributed cache specifically, where you can where you have to implement some kind of eviction policy. So it is easily mentionable on on that high level design, and as well as on the low level design, where you have to definitely implement it in a very optimized manner. Because now let's discuss, like it's here I've shown the the question, where it is that designing a data structure that follows the constraint least recently used cache. Implement LRU cache is, we need to give it a capacity, which is a positive size integer, and we need to have a get method. We need to have a put method. Okay, and for the key we need to return that. Other, if key is not present, then we need to return the -1. So it is very heavily relying on the asking, the scope is on the number and only. Okay, so we need to be only worrying about the numbers. But yeah, it can be lay a foundation to develop a cache, because it's if you thinking about that, map also have a get input, but map do not have the eviction policy that we need to, that whichever the least recently used, or you know which is not necessarily needed and capacity is full, then which key we will be deleting. So this is the algorithm we need to think about. Okay, and here for the simplicity they are asking for the number, but yeah, you can consider it like anything, like any data structure, arrays, text, strings, JSON, anything like that. Okay, also in real world the cache has also a TTL. Here this is also not you know in the picture, and assuming underlying map or underlying whichever thing we are using, Redis or anything, it will have those kind of implementation details. So we just need to focus on algorithm. Okay, yeah, we will be introducing some data structures, and which one is primary, one is secondary. So let's start with this. So the first main thing we need to have in mind, like we have to somehow find out which is least recently used and which is most recently used, which means we need to have some kind of timestamp attached to it, maybe, and then we will filter out based on timestamp, like which is least usually and frequently used, and we find out from the. So we need to have a separate record in which read entries will be putting, and we will then on the on the put time, when we need to delete something, when the capacity is full, we need to find out which needs to be evicted. So we will filter out from those list of the record. It will increase additional, apart from getting and putting the data, additional resource where we need to have those. But the problem is the filtering part. We need to first sort it, then is n log n, then it will be O of 1, like which is the recently but for every enter we need to sort it, or we need to use linear search. But which, from which point you will be comparing? So in either case you need to either find the least recently used by comparing in with the nested loop, or we need to use some kind of sorting involved it. Both have n log n capacity. So at the time of putting we need to have n log n, but yeah, get is very fast. So as we can have in mind, like we can we need to improvise, or we need to optimize that put thing. Okay, either if we have few sort of all possibilities, few more possibilities to do it something, then we will be hampering maybe on the get side. So for our goal is to have it like in question as well, the function get and put must be run in O of 1 average time complexity. So for O of 1 we need to have something that get should be just O of 1. For getting and putting we are using hash map. We will be using hash map because it's key value here, and for that we are sorted, it's O of 1 approximately. But for eviction thing, we cannot maintain a record, as as we seen, like we will be ending up doing sorting, which will be n log n. So the next thing is that if we are doing it sorting on the binary search thing, log inside also, that is not getting very intuitive in nature. So we are simply heading towards what is most marketized or popular thing, which is reading from a linked list. Okay, as we know, reading from a linked list, if it is ahead, then it is very O1. But if it is in between or if it is last, then again it's an O of an operation, and also the sorting is involved there also, or not. So to solve that reading problem, and to solve the approach, we will be using doubly linked list. And let me explain why. The approach is, the intuition is that for every entry, we will check either on get or put that if it is existing or if it is a newly entry, then it should be put ahead of time in the head. So at the time of at the time of getting it or at the time of putting it, we are replacing, because that is the most, or that is the the what is that, the latest read value. So we are putting it on the head. You will get to know why. Now when the time of putting is there, which position is least read, least recently used, it will automatically getting end up at tail. So we can simply remove the tail and we are good to go. We can simply put it the new value at the head. So in this case, deletion is also O1, reading, inserting at head is also O1, and we are reading from the hash map, so that is also O1. So it's look like it can be intuitive. Let's go ahead and with the solution. So the core analogy, the core approach is that we are inserting new value, and while reading a value, we are inserting that also, switching the connections and moving it to the head, so that all our read value automatically gets into the arrangement that most recently used is on the head, and then lesser, and the least recently is automatically get in the tail. Okay, if it is in the tail, that is the sign that it is not recently been used, but otherwise it will be in the head or in somewhere middle. So that's the approach. Let's try it with it. So as we using intuition of linked list, and then we need to have a load. And as I told you, we are using doubly linked list because we need to also remove from tail, and to directly access the tail, we need to have a doubly linked list, because we can move back forward as well. And in the doubly linked list, we have two pointers. So let's start with it. Okay, and also our node will also have the value of the key and the value. Why? Because when we reach the node, we can read the value as well. But to reach the node directly, when time of reading get you are you are getting that answer, that how we end up reaching middle of the value at the time of getting. Okay, because once we find that node, we can easily switch the connections. But how we find it? So for that, we are using hash map to get O1 rate. So for hash map, we are using key and the node. It was so yeah, it will be a trade-off on the capacity, and like we are using two different data structures to accomplish this. But yeah, it will give us more intuitive thing and more O1, which is heavily asked here. So it will have a key. Okay, once it will be set, so it will not be updated, so we can make it private read only as well, and it will be a number here. Okay, we can use generics and make it any data structure. For any data structure, we will be having value which can be updated, so we will leave it there. And for key also, we need to read it. So okay, so for now we can read it. Okay. Or either we can update it at the time tab, but it's up to you. Okay, the main code logic, we are getting ahead with that. So previous, it will be node or null. Next will be node or null. Then we have a constructor. we will be passing by key. Okay. By, yeah, while recording, the writing of the code is very, mistakes gets in it. So this dot key will be key. This dot value will be value. Okay. And we can initialize them with null. Okay. Now, so this is the node. This is the node. Okay. Now, at the here we need to have both reference of both thing, head and tail, okay? Because from the reference we are traversing it. So private read only, because our head and tail, why I'm using private read only, you will get in a second. And I'm not using it here null, because we are using that dummy node thing here as well, where we will have a dummy head and dummy net tool. So our switch of connection will be much easier. We don't have to, take care of edge cases where head is null or tail is null or whatever previous connection is available or not. For having head or tail, every time head next and previous some have some type of value, so we don't need to put many checks in here and there. Okay, we need to have a map for O1 lookup, read only map, which is, as I said, for lookup we will be using key, but the answer will be not, and answer will have the value. Okay, and also we will having a capacity, our local private variable, so that once it's set it cannot be changed, and also it's a single source of truth. Now on the constructor we will be setting a capacity. Okay, capacity. Now, as I said, that the head will be some node, the dummy node. So we are initializing it here. -1 is the value which will not hurt. Okay. And what we have, we need to initialize map with the new map. Or here, yeah, here we need to have number. Yeah. And node. Now, one more thing is the connection of the W link list needs to be very crucial, because if we have two separate nodes and they are not connected, then how will they serve, what they made for purpose for? Because on previous, on next, we need to have some reference. That's why head and tail are, initialized with dummy node. So we need to establish the connection or not. Connection as well. So this head will initially it will be empty. So the previous of head is it's null because it's expected to be null. The next is pointing to tail, same as the tail would be the last. So next will be null. The previous of next initially will be head, because they are only two nodes there in the linked list. Now I'm starting with the algorithm so that it will be intuitive to follow, and we will be, because there will be some helper function involved in it, we will write them after the main core logic. So first we will always check if our map has or not have it or not. So map dot has, if it has the key, then it's the main logic. If it does not have the key, then from the question we will simply return -1 and we are good to go. Now if it is having a key, let's get that node, because the map has the reference to the node. So map dot get key. Now we will not, we do not have the value yet, we have only node. Okay, but, and let's return node dot value. But our core logic for LRU cache here is to remap that node, because it's just recently asked and recently read. We need to rewire it to head, so that our linked list is very good to go, to know, yeah, it's been sorted in a way that which is recently used, which is least recently used. Okay, and assuming if it is the first node, then it will also work in it. So we will detach it from wherever it is. So we will be having a function delete node or detach node. Okay, still we have node, we have just cut it out the reference, because if we are simply directly referencing it, then it will be a problem. So first we delete it, detach it from the menu list, and then we will insert add head. Now you're thinking like where this functions come from. So these function we will be implementing through Let's mark this because they will be now this get is very sorted. Okay, so we are checking if like, like crossing the edge case, then we are making simple get and getting the node. This node will be definitely there because the not having condition is also already been taken care just one line ahead, one line above. The delete node will be there and then inserted ahead. Okay. Okay. Now for the put is also if map has or not is. So map dot has key. Okay. And map does not have key. In both of the cases, there will be slightly difference because if this map has the key, then we need to only update it and same rewiring stuff because it's been read. If we are putting something at the time, that is the also consideration of the case where it's read also. Okay. And suddenly if it does not have key, then we need to create a node and we need to insert in the previous in the correct position. Let's use that update position because here we don't need to worry about the capacity because it's if it is already in the node in the linked list, then we just need to update it. We don't need to shrinking, deleting or something stuff but which is the main neat part and main part of this algorithm. So let's first get it because it's there. So node this dot map dot get key, and here as I can see I'm using the map but I'm not using this and it will shout at us. Also one more here, let's check over. Yeah, so we will have the node, we will simply update the node value because it's already exist. Now since we need to rewire it, it's recently read, so delete node from and then insert it at this dot insert at head node. Okay, and since it's a void, we don't need to return anything. Now the next case, in this case, either the case if the capacity is full or not, we are using two cases. If the capacity is not full, simply insert it, forget. If the capacity is full, then we need to delete it. Okay, and delete it from the tail because tail would eventually get have the least recently used. So you know start with creating a node because for the each case we need to have a new node and new node with key and value. Okay, now we check if this dot capacity, okay, and are is less than or equal to, because it's exceeded this dot map dot size is the main source of truth. So if size is greater than or equal to the capacity, we need to evict it something, otherwise we will simply insert it. Okay, so we need to have that node which is just before the tail because tail it's a dummy node. So the node which is, we can make it tail node, this is tail dot tvs, and we simply delete it, delete this dot delete node tail node. Also we need to delete it from hash map as well. So this dot map dot delete and we need to provide the key. Okay, so we are good to go here. Now in either case, if it is full, then we need to delete it. If it is not full, then we do not do anything. We simply insert the new node at the position. So first we make it in a reference at map. So set, we can do it. It's a sequential thing. And this dot insert at head new node. Okay. So this is the whole main algorithm. Now we need to make these two functions also here. So and we need to make it private because they are only concerning to this class only. So private delete node, it will every time it will get node, but we don't have to mark the type as null and check for it. Okay, can make it void. So we have the node. To change the connection, to delete the node from previous and from the next node, we need to remove its connection. Okay, node can have its connection, but node's previous node and node's next node do not have to connect, should have connection of this node. Okay, so what we do, we will store that connection first, because we need to preserve the connections which node has reference to, because that's the mean we can connect the node's previous to its next, and vice versa. So node's previous we get from nodes dot previous, and node next. Okay, now node it's ready to be free up. We have both its references, but it's a job of garbage collector to get it. We need to just check the connection. So previous next should be this next. We are skipping our node because earlier it was our node, this node which has been passed, now it's next. And the next previous, which was this node, now it's now the node's previous value. Okay, so this just we are cutting those connection which was pointing to our node. Okay, now previous is also should be there, next should be not to be changed because they are good already. Now the insert add head thing, again we will be having some node here, so we don't need to check about for the. Okay, now for inserting at head, we need to make the preservation of connection which is currently at head. Okay, so we will be getting that what we can say the next, because the heads next is the head node, so head next. Now previous we don't need because it's already null, so this dot head dot next is now our node. Got it? And our nodes previous should also be pointing to head, so our nodes connections to head are sorted. But now nodes next sit between the earlier two nodes, so the next node should be this now next nodes. Okay, and obviously the next node should was previously known, it's previous to be the head, now it's this node, so next dot previous should be this new node I've created, and that's it. These are the connection we need to check. You can verify it. Now there might be some syntactical issues or maybe some logical issues. Since we are not updating anywhere the key, we can make it private. Okay, we can make it private because we are essentially dealing with only value if we want to change it here. So I think there will be no issue for us. Let's try to run it for the cases. Let's check what happens now. If we are getting any TTL, we are doing something wrong here and there. Let's check. It's taking too much time. Maybe let's wait for it. Maybe something wrong is with internet. Let's refresh the page. Okay, looks like lead code is facing some kind of downtime or some slowness issue. It's not giving up results. I've tried on refreshing and all that. It's also showing very slow reloads. Other websites are loading fast, so my internet is good, but lead code is maybe facing some problems. So, but you understand it. I have verified the code. I have explained it, try to explain it in my good way, and the approach is, I think it will be cleared. Few things, maybe a syntax issue and maybe some logical issue we will be finding. So we can discuss it on the comment. We can comment it down below. Any naive question, any question where you think it's silly and you will be judged upon, don't hesitate, ask it. I will not be knowing who is commenting on it, and who am I to judge? I'm also in the learning process. I also ask very naive question, very basic and very to the point question, so that yeah, it can be answered. It get much clarity on my mind also. So don't hesitate, and I will find some question answer. Of course, most of the time, I still am in the learning process. So I'm that there is a high cache miss. You will getting like I don't have question map, and here we got our this dot map. I think I fixed that already, but I don't know how it got it. So we will be trying to answer and getting the clarity for every possible scenario. We get here. It's very slow. Yeah. So we can leave it here. You can try the code and let me know whatever the query you have. Thanks for watching this video.